Here are some more examples of some absolute value inequality problems. So solve and graph the solutions to the absolute value of 2x plus 7 plus 27 is less than 15. So we would have to isolate the absolute value first and subtract 27 from each side, which would leave us with the absolute value of 2x plus 7 is less than negative 12. The left-hand side is non-negative for all x. Absolute value is non-negative. But the right-hand side is negative. We're less than negative 12. The left-hand side cannot be smaller than the right-hand side, so there are no solutions for this problem. Here's the absolute value of 2x plus 7 times 2 plus 15 is less than 23. So we have to isolate the absolute value first. So they're going to subtract 15 on both sides to give 2 times the absolute value of 2x plus 7 is less than 8. Then they're going to divide both sides by 2, which will leave the absolute value of 2x plus 7 is less than 4. We have D is greater than 0, so we can now think less than is an AND compound inequality, where we have 2x plus 7 is greater than negative 4 and less than 4. We're going to subtract 7 from both sides, or all sides, which leaves negative 11 is less than 2x, which is less than negative 3. And we're dividing all sides by 2, which leaves us with negative 11 over 2, or negative 5.5 is less than x, which is less than negative 1.5. We have negative 5.5 with an open circle, negative 1.5 with an open circle, and then we have all the shading in between. So our solution to this inequality, 2 times absolute value of 2x plus 7 plus 15 is less than 23, is negative 5.5 is less than x is less than negative 1.5. Here's another example. We have 2 times the absolute value of 5x plus 3 minus 15 is greater than 51. We first have to isolate the absolute value, so we're going to add 15 to both sides. So that will leave us with 2 times the absolute value of 5x plus 3 is greater than 66. We'll divide both sides by 2, which will leave us with the absolute value of 5x plus 3 is greater than 33, which think greater is an OR compound inequality, greater. So we're splitting this up as 5x plus 3 is less than negative 33, or 5x plus 3 is greater than 33. We're solving each inequality individually. We're subtracting 3 from both sides. We're dividing by 5 on both sides, which leaves us with x is less than negative 7.2, or x is greater than 6. So we're marking negative 7.2 and 6 with open circles, and we have our shading to the left or to the right. Here is another example, again, of just practicing isolating the absolute value first. We have 7 times the absolute value of 6x minus 5 plus 11 is less than 18. So again, we have to isolate the absolute value. So we're going to subtract 11 from all sides first and then divide by 7, which will give us the absolute value of 6x minus 5 is less than 1. This is less than an AND inequality, so we can rewrite it as negative 1 is less than 6x minus 5 is less than 1. If we add 5 to both sides and then divide by 6, we'll end up with 2/3 is less than x, which is less than 1, which we're marking 2/3 and 1 with open circles on the number line and shading everything in between. The key to these problems is to isolate the absolute value first, and then you can split into your AND or your OR.